Hello students, I welcome you all in this new session where we are going to discuss some concepts on physics, right? So this is the paper actually, AIATS plus 2025, this is phase 2 and the paper was mock test number 5 and it was conducted on 16th of Feb 2025, right? So let's see the other slide. These are the chapters which I am going to discuss. The first chapter is electric charges and fields, electrostatic potential and capacitance, units and measurements, motion in a plane, and mechanical properties of fluids. As you can see, these two topics are from your 12th class, right? And these three chapters are from your 11th class, okay? So we are going to discuss some questions, and around those questions, we are going to build concepts, all right? So let's see the first question then. This is the first question, and it says, in a region, the intensity of an electric field is given by E vector is equal to 2I cap plus 3J cap plus K cap in Newton per Coulomb, right? The unit is given here. The electric flux through surface S vector is equal to 10 J cap meter square in this region is, all right? So we have to find the electric flux, okay? Electric field is given, area vector is given, and we have to find the electric flux. Let's see the concept first, all right? So the concept is, this is, let's say, electric flux. It is denoted by this phi is equal to integral of E vector dot dA vector, all right? So if electric field is variable, then this is the fundamental formula, okay? This is the electric field and this is the area vector, very small, infinitely small area vector, and then we have to integrate it to find the total flux, okay? Now, if electric field is constant, if this is constant, then we don't have to integrate it, okay? So what we can do is, we can write phi is equal to directly E dot A vector, or we can also write E A cos of theta, okay? So if electric field is constant, then we can use these two formulas, two forms of this formula. One is E vector dot A vector if the vectors are given, and also we can write magnitude of E means magnitude of electric field, magnitude of area, and the area or the angle between these two vectors. या दशरथ, इसी क्वेश्चन का कॉन्सेप्ट हम लोग बिल्ड कर रहे हैं, ऑल राइट? Okay, good afternoon everyone. Good afternoon. So this is the concept. We are discussing flux, electric flux, and this is the formula of electric flux. So let's see the question now. Okay, so E vector is given, area vector is given. We have to find the electric flux. So phi is equal to, again I will write E vector dot A vector. Okay, so this is E vector, that is 2I cap plus 3J cap plus K cap, right? Dot A vector, this is 10 J cap, right? And the unit will be unit of E, that is Newton per Coulomb, and unit of area is meter square. Dot product, we know how to do the dot product of these two vectors. So 2I cap, there is no I cap, right? So it will become 0. 3J cap, and is here this is J cap, right? So this will become 3 into 10, right? 3 into 10. Again, there is K cap, but there is no K cap here, so it will become 0 again. So the answer will be 30 Newton per Coulomb meter square. Can we see which option is correct? So option 3 has our answer, right? 30 Newton meter square per Coulomb. This is the concept of electric flux, okay? Is it clear now? Any doubt in this topic? No? Okay. Let's move to another question then. This is the another question. It says, two capacitors of capacitance 2 microfarad and 5 microfarad, which are connected across a 7-volt battery in series as shown in figure, right? After long time, the battery is replaced by a closed switch. The common potential across the two capacitors is, we have to find the common potential, okay? So this is 7-volt battery. These two capacitors are charged with the help of this battery. Then this battery was replaced by a switch, or you can say a wire, right? Then both are both will be connected and we have to find the common potential of these two capacitors, right? Okay. So let's see the concept here. Let's build the concept, okay? So the concept is like this. Let's say there is a capacitor C1. It is being charged with some battery of potential V1. So what would be the charge on this? So let's say this is Q1 plus Q1 and this is minus Q1, okay? A capacitor, an uncharged capacitor has always equal and opposite charges on its two plates, right? So the total charge on a capacitor is 0. But whenever we talk about the charge on a capacitor, we only talk about the charge on its positive plate, all right? So what is Q1? So we know the formula, right? Q is equal to CV. So this will become C1 V1. Similarly, there is another capacitor. Let's say this is C2. It is being charged with V2. Let's say the battery has potential V2. So the charge will be plus Q2 minus Q2. Charge will be Q2 is equal to C2 into V2. All right. So these are the two capacitors. Now what we will do, we will connect these two capacitors like this. Okay. Now what will happen? See, if these two potentials are different, initially this is at potential V1 and this is at potential V2. If two conductors are at different potential and we join them by a wire, what will happen? The charge will flow from higher potential to lower potential such that the final potential will become same, right? So finally what we will get, that let's say the final potential is say some V prime. So the potential difference is V prime here. Again the potential is V prime here. The final potential will be same. What will happen? Let's say this was initially at plus Q1 and this was at initially plus Q2. Okay. These positive plates are connected with each other. What will happen? The final potential, the final charge is, let's say, Q1 prime here and Q2 prime here. Okay. Now Q is equal to CV. This is always applicable. So I can also write V is equal to Q by C. We can write this Q by C. So V prime is equal to Q1 prime by C1 and V prime, this V prime can be written as, for the capacitor C2, Q2 prime by C2. After solving that, we get the direct formula. Okay, so you don't have to like always derive the formula. I am writing that formula directly. That will become V prime is equal to total charge, that is Q1 plus Q2 divided by total capacitance, that is C1 plus C2. Let's see why I am writing this formula. So if you can see in the figure, there are two capacitors and these two capacitors are connected to each other in a parallel combination, right? So what will happen, that let's assume that this is a single plate of a equivalent capacitor. Okay, so the total charge will become Q1 prime plus Q2 prime, or Q1 plus Q2, because the charge will remain conserved, right? So that will become Q1 plus Q2. What will be the C equivalent? Both are in parallel combination, right? So that will become C1 plus C2. So total charge by total, or C equivalent, right? So that will become Q1 plus Q2 divided by C1 plus C2. Now if we don't know Q1 and Q2, we know what is C, what is V, then we can also write Q1 as C1 V1 plus Q2 as C2 V2 divided by C1 plus C2. This is the final formula. Okay, you can apply this formula directly. You don't have to derive that formula again and again. Is it clear? Okay, let's solve the question then. So the formula is V prime is equal to Q1 V1 plus Q2, this is Q1 plus Q2 divided by C1 plus C2, or C1 V1 plus C2 V2 divided by C1 plus C2. Q1 V prime is equal to, if this is being charged with a battery and these two are in series, then this is Q, this is minus Q, this is plus Q again, this is minus Q. What will happen when these two are connected with a single wire? This will look like this. Okay, I am rearranging this. Okay, so these are in series now, but you will find that if this is connected with a wire, then the arrangement will look like this. So this is Q, this is Q, no, this is minus Q, this is minus Q, and this will be plus Q. Can you see this? This is 2 microfarad plus minus. So this is plus minus. I took this 5 microfarad capacitor and it is being connected like this. Okay. So this will be 5 microfarad, and with minus Q, this is plus Q. So minus Q and plus Q here, and this is minus Q. What is the total charge on these two plates? What is the total charge in these two plates? It is 0 obviously, right? So this will become 0. What is the total charge here? Again 0. So 0 plus 0, C1 plus C2, that will become 2 plus 5, but it would be meaningless because the answer would be 0. So the final potential difference across these two capacitors when they are connected like this will become what? 0. So this is the answer. Right? Any doubt so far? So have you understood this concept? Because this is very easy question, alright. The question which is given was very easy. But this is the fundamental concept, and with the help of this concept, we can solve other type of questions as well. Okay? No doubt so far? Let's move to another question then. This is the next question. Given that y is equal to a cos of t by p minus qx, where t is time in second and x represent distances in meter, which of the following is true? This is the equation. Y is equal to a cos of t by p minus qx. Okay, what is the concept here? Anyone? Just tell me the name of the chapter. Okay, are you guys listening? What is the name of the chapter from which this question belong? Anyone? Unit and measurement, right? So this is the question from unit and measurement. First chapter from physics, right? Unit and measurement. And there are actually two types of concept which are involved here. What are these concepts? So first concept is concept number 1, quantities. And what type of quantities we are talking about? Physical quantities, because we are dealing in physics, right? So quantities can be quantities with same dimensions. Okay, same dimensions can be added or subtracted. Okay, you cannot add two quantities with different dimensions, or you cannot subtract two quantities of different dimensions. Alright, you can multiply and divide them, but you cannot add or subtract them. You cannot add energy with force. Okay, so quantities with same dimensions or dimension can be added or subtracted. This is the first concept. What is the second concept which has been used here? The second concept is that there are some operators, or there are some mathematical operators or functions which has their argument as dimensionless. For example, trigonometric functions has dimensionless arguments. Dimensionless argument. What do I mean by that? Let's say I write sine of theta. Okay, so this is a trigonometric function, sine theta. This theta has to be dimensionless. This theta has to be dimensionless. Okay. Let me write the correct spelling. So this is dimensionless. Okay. Similarly, this is true for cos theta, tan theta, and other trigonometric functions. Now, okay, so this is theta and theta is dimensionless. Similarly, this cos theta, argument of cos has to be dimensionless, argument of tan has to be dimensionless. Alright. Now, in place of theta, there could be another function, but that function has to be dimensionless. Alright. What are the other functions? So there could be many functions, but I will give you the functions which we use in physics, which we use in our physics. Alright. So trigonometric functions has dimensionless argument. Similarly, what else? E to the power x, exponential function has dimensionless argument. This x has to be dimensionless. Okay, this x has to be dimensionless. Similarly, logarithmic function, log of x. Okay, you must have studied this logarithmic function. This x has to be dimensionless again. Okay, now these are the two concepts which have been involved in this question. Now can we solve this question? Okay, so let's go to the question then. Any doubt so far? No? Okay. So y is equal to a cos of t by p minus qx. Okay. Is this a trigonometric function? Cos of theta, right? So this is a trigonometric function. It means this is its argument and this has to be dimensionless. Alright, this has to be dimensionless. Now, if this has to be dimensionless, then this part has to be dimensionless and this part has to be dimensionless. Are you getting this? Why? Because two quantities with same dimensions can be added or subtracted, right? So these two quantities, first is this, another one is this. This has to be dimensionless. And now, if this is dimensionless, then only they can be added or subtracted, and the whole quantity has to be dimensionless. Okay, so t by p is dimensionless. This t by p is dimensionless. Again, this qx has to be dimensionless. Okay, now if t by p is dimensionless, then what will happen? Dimension of t should be equal to dimension of p. Why? Because then only the dimension of p and t will get cancelled and we will get the dimensionless quantity. Similarly, dimension of q should be equal to 1 upon dimension of x. Is this clear? This is clear, right? Dimension of t and dimension of p will cancel each other. Therefore, we will get a dimensionless quantity. Similarly, dimension of q and x should be dimensionless, right? It should be 0. So, dimension of q has to be equal to 1 upon dimension of x. Okay. So, this is the analysis which we need here. Now, can we solve this question with this concept? Okay, let's see. The unit of x is same as that of q. No, the unit of x has to be inverse of q, right? So this is wrong. Option 1 is wrong. The unit of x is same as that of p. Okay, so now x is here, p is here. Okay, is it possible that the dimension of x could be same as that of p? Let's see. So dimension of t by p has to be equal to dimension of q into x. Now, what we were talking about, unit of x is same as that of unit of p, x and p, right? So we have to compare x and t. The dimension of x is t by pq. Are we getting dimension of x as equal to dimension of p? No. So this option has to be wrong then. So this is also a not a correct option, right? What about the option number 3? The unit of t is same as that of q. the unit of t is same as that of p, it is not equal to q. Again, you can do that, the analysis like that. What you can do is, I can write dimension of t as dimension of q x by p. So dimension of t is not equal to dimension of q. Is it okay? So option number 3 is also not correct. The unit of t is same as that of p. The unit is t is same as that of p. That is correct. And option 4 is correct. Okay. So that's how you do analysis of dimensions. There are two concepts which I have taught you. One is quantities with same dimension can be added or subtracted, or you can also add one more topic here or one more concept here, which is if there are two different kind of quantities or different quantities with different dimensions, then they can be multiplied or divided, but they cannot be added or subtracted. What is the concept number 2? Trigonometric functions, exponential functions, that is e to the power x, and logarithmic functions, that is log of x. The argument of these functions has to be dimensionless. Okay? Any doubt so far? Any doubt? No? Let's move to another question then. The tangential component of acceleration of a particle in circular motion causes. Okay? So we are talking about the tangential component of acceleration. What is the another component of acceleration? What is the name of that component? Write in the comment box if you know about it. Another component of acceleration? No one? So if there is acceleration, okay, so there are two types of acceleration. One is tangential acceleration. Another one is centripetal acceleration. And it is also called normal acceleration. Normal, because normal means perpendicular, right? So this centripetal acceleration is always perpendicular to velocity. That's why its name, one more name is normal acceleration, and the other one is radial acceleration. Okay, what is the reason for being radial acceleration? Because it is along the radius or radial direction. Okay, so these are two different components of acceleration. This is tangential acceleration is responsible for change in speed or change in magnitude of velocity. Okay, this is responsible for change in magnitude of velocity. Okay, Zakia. Okay, you have given option number B. Okay, we will go to the question after that. Okay. All right. So this is change in magnitude of velocity, which is caused by tangential acceleration. What about the centripetal acceleration? Can you tell me? Okay. So centripetal acceleration causes change in direction. Change in direction of velocity. Okay. So there are two things associated with velocity. One is direction and the other one is magnitude, right? So tangential acceleration causes change in magnitude of velocity and centripetal acceleration causes change in direction of velocity. Both the components are dealt with. Okay. So what would be the answer now? The tangential component of acceleration of a particle in circular motion causes change in the direction of velocity? No, it is caused by which acceleration? Centripetal. Okay, centripetal acceleration. Change in the magnitude of velocity. Yes, this is the answer. Change in magnitude of velocity. What about 3? Change in both magnitude and direction of velocity? No. Change in magnitude and direction. Okay, both is caused by net acceleration or simply acceleration. Okay, no change in magnitude and direction of velocity. That is also wrong. Have you understood this question? There are two types of acceleration. Any doubt, guys? Any doubt in this question so far? No? Let's move to another question then. In a hydraulic lift used at car service station, the radius of the large and small piston are in the ratio 10:1. What weight placed on a small piston will be sufficient to lift a car of mass 1000 kg? Okay. Tell me the name of the chapter as well as the concept which we can use here to solve this question. Students, yeah, in place of fighting with each other, you can tell me the name of the concept. Any answer? Okay, so this question is from mechanical properties of fluids. Okay, and the other concept which is used here is Pascal's law. What is Pascal's law? If we increase pressure of a confined fluid at a point, or I should write this as confined liquid, okay, at a point or at any point, then the same increment of pressure happens at every point in the liquid, okay, or I can say the same change in pressure transmit at every point undiminished. Yes, everyone. Janak, yeah, Sukanya, Eldorado, yes, it is from Pascal's law. All right. So if we increase pressure of a confined liquid at any point, then the same increment of pressure happens at every point in the liquid, and that pressure is transmitted, or we can say that the same change in pressure happens at every point, or pressure transmit at every point undiminished. Okay. Now let's see how hydraulic lift work. So hydraulic lift is designed like this. There are two limbs. Okay. This is limb which is a thin, okay, its area is thinner, with its area is lesser, and this is another limb. Okay. Now if I apply force F1 here, and if I apply force F2 here, this is, let's say, area A1, this is area A2, and if both of them are balanced, okay, so by applying force F1 on this area A1, let's say I have increased pressure as P1. So this is P1 is equal to force divided by area, right? So this will become F1 by A1. This is my equation number 1. Now, this is the increment in pressure at that point. The same increment in pressure will transmit to this point, same increment in pressure. So I write here Fp2. Now to balance that pressure P2, the force, okay, the force is applied F2 here. So Fp2 is equal to F2 by A2. And if both of these pressures are equal, okay, according to Pascal's law, so P1 is equal to P2, this will become F1 by A1 is equal to F2 by A2. This is the formula which can be applied or which can be used in solving this hydraulic lift questions. Okay. So now can we put this values here? So first you have to analyze the question. what is F1, what is F2, what is A1, what is A2, then only we will be able to solve this question. Yes, Marsh testo. Okay, so you are giving me 10 kg as answer. Okay, Sukanya, option 1. Let's see. Okay, so radius of the large and small pistons are in the ratio 10:1, and how much weight we have to apply on a smaller piston to lift a car of mass 1000 kg. Okay, now let's see. So car is of 1000 kg, right? So I am putting 1000 kg here. Or let's make another figure. This is the liquid. Okay, this is the liquid. This is the car of mass 1000 kg. Okay, this is area A2, let's say. This is area A1. I am again putting another mass here of mass M, let's say. Now, we have to balance this one now. So what is happening here? This is 1000 kg is its mass. What would be the weight? That is M into G, that is equal to 1000 into 10. Okay, so P2 is equal to F2, that is 1000 into 10 divided by A2. What about P1? So I am putting here mass M, weight will be M into G, that is M into 10 divided by A1. Both of these pressures has to be equal, then this will become P1 is equal to P2. Okay, so this is 1000 into 10 divided by A2 is equal to M into 10 divided by A1. This 10 and 10 will get cancelled out. 1000 divided by M is equal to A2 by A1. Okay. Now A2 and A1 we have to find out, because final answer should we have to find the mass M, right? So A2 by A1 is given here. Radius is in the form of, or is in the ratio of 10:1. Okay. So this should be 10A and this should be A. No, this R1 is, let's say, R0, then R2 has to be 10 R0, right? So what would be the ratio of area? That would become 1000 divided by M is equal to area is pi R2 square divided by pi R1 square, let's say. Okay, so pi and pi will get cancelled out. R2 will be 10 R divided by R the whole square. R and R will get cancelled out. This will become 1000 divided by M is equal to 100. So M would be 10 kg. The answer would be in SI unit, right? Because we have used the mass of the car in kilogram. So answer is 10 kg. Okay, so two students have told me or given me the correct answer. Okay, 10 kg and option 1 by Sukanya. Any doubt in this topic? Any doubt so far? No? Okay. Let's see another question then. Okay, so I would like to ask you another question from this. So as you can see, if we analyze this question, then here the mass is 10 kg, right? So with the help of 10 kg, I can balance 1000 kg, right? So this is 10 kg and I am balancing 1000 kg here with the help of this. So force magnification is happening. What about the energy? Will it be conserved, or is it happening that I am applying here 10 joule, I am giving 10 joule of energy here and I am getting 1000 joule energy here? Because this is 10, this is 1000, right? So corresponding to 10 joule, I am getting 1000 joule here. If this happens, if this works like this, then I can magnify energy also. Any answer? Is it possible that I can give 10 joule here and I can get 1000 joule here from this mechanism? Because I am magnifying the force, can I magnify the energy? Any answer? So, no, actually. We can magnify the force, but we cannot magnify the energy because the energy is always conserved, right? So, if you give 10 joule here, then you will get 10 joule here. You cannot get more than 10 joule here. Actually, there will be some energy losses also. So, energy will be conserved. It is not happening here that it violates the energy conservation principle. Okay, very nice. Okay. So, this is the next question. For a projectile motion, so you get the option or the name of the chapter already. This is from the projectile motion. For a projectile motion, an xy plane on some planet, the position coordinates as a function of time t are given as x is equal to 4t and y equal to 14 minus 5t square, where x and y are in meter, time is in second. All right, everything is in SI units. Assume x is horizontal and y is vertical. The horizontal range of the projectile is, okay, x is horizontal and y is vertical. These two equations are given, x as a function of time, again y as a function of time, and we have to find the horizontal range of the projectile. All right, so let's see the concept of projectile motion then. This is x, this is y, this is the trajectory of the projectile. Initial velocity u. I have already discussed this topic in my last lecture also, which I took on last Friday. Okay, so this is u, this is theta, this is some acceleration a. Why I am using this acceleration as a? Because it was given that it might be happening on some another planet. Okay, so it is not compulsory that acceleration has to be equal to g only. It could be anything. So I am writing a here. Okay, now we know this is r, this is range, this is maximum height, and what is the another parameter which is standard, which we use here, that is t, right? Time of flight, t. So r, h and t. Now just by observation, what is happening here, let's see. Okay, so this is y. So when the particle is projected from here, its x is increasing, right? Its x coordinate is increasing, its y coordinate is increasing. It will become maximum here, and then after that its y coordinate will start decreasing, but even now its x coordinate is increasing, right? So its x coordinate is increasing continuously, but its y coordinate is increasing first, and after that, after reaching maximum height, it will start to decrease. What will happen here? As you can see, this is 0, 0, right? This is again, this will become r, 0. So at the maximum horizontal or at the point of range, when it will strike the ground again, its y coordinate will become 0. Okay, its y coordinate will become 0. How can I use that concept here? So x is equal to 40 and y equal to 40 minus 5t square, right? So I am writing equations as x is equal to 40 and y equal to 40 4t minus 5t square. Okay, how can I solve this? I have to find the horizontal range. Okay, so to find the horizontal range, let us find the time first when it will strike the ground. That can be find out with which equation? So I can put y equal to 0 here. Why? Because when it will strike the ground, its coordinate will be 0 again. So 0 is equal to 4t minus 5t square. 0 is equal to, I can take t common from both these terms. So this will become 4 minus 5t. Okay, that is equal to 0. So the roots which I get from this equation is t equal to 0 and 4 minus 5t is equal to 0. It will give me t equal to 4 by 5, right? So these are the two roots which I am getting from this. Okay, it's me. Sir, can you please provide full PDF of this test solution? But I don't know how can you find the PDF. Okay, so but in these sessions, okay, the sessions which we have conducted from the morning only. So there are 5 lectures of 1 hour each. You can get every solution here, okay, or whatever the solution you require, you can go go into that session and see the solution. All right, so that's how you can get the solutions of questions which you found difficult. All right, so t equal to 0 is one root and t equal to 4 by 5 is another root. All right, why we are getting these two roots? What is the significance of this first root, t equal to 0? So at the point of projection, the time was 0, right? And y coordinate was also 0. That is why we are getting t is equal to 0 as one of the solution. What about t equal to 4 by 5 second? What about this? So obviously t equal to 4 by 5 seconds I am getting from here because of this point, right? So this is the time of the flight, t equal to 4 by 5 seconds. This is time of flight. Now how can I use this time to find the horizontal range? How can we do that? We haven't used this equation, right? X is equal to 40. What is this equation? This equation is telling me that how its x coordinate is changing with time t, right? So at this point, what is the x coordinate r? So I can use this equation, x is equal to 4t. I can write x is equal to 4 when time is time of flight, right? That is the maximum horizontal range. So this will be equal to 4 into t is equal to 4 by 5, that is 16 by 5. Okay, answers are given in, okay, in this form only, right? So 16 by 5 meter, everything was given in SI units, so the answer would be in meter obviously. Option 4 is the correct answer. Option 4 is the correct answer. How many of you got this correct in your exam also? How many of you got this correct in your exam? No one? Huh? It was difficult? Was it difficult? Because if you can analyze these questions or these mathematical equations, then this question is quite easy, right? Okay. What else can we find out? What else? So we have already calculated the time period, right? We have already calculated the horizontal range. What we can find out? What else? Maximum height. How? Anyone tell me how we can find the maximum height? So y equal to 4t minus 5t square. One thing we can use is that this motion is symmetric from here, right, to here. So if this is the total time, t is the total time, then motion up till here will happen in t by 2 and from here to here in t by 2. Okay. So the time to reach the maximum height will be t equal to t by 2, where t is 4 by 5, right? 4 by 5 divided by 2, that will become 2 by 5 seconds. Okay. What is this equation? This equation gives y coordinate as a function of time. So I know that this will become h, maximum height, after putting t as 2 by 5 minus 5 into 2 by 5 square. Alright, this is 8 by 5 minus 5 into 2, 4, 5 into 5. This 5 will get cancelled with this. So this will be 8 by 5 minus 4 by 5. Answer will be 4 by 5 meters. This is the maximum height. One method is this. Can you tell me another method? Can you tell me another method? No? It involves a little bit of differentiation. Okay. So another method. What else happened at this point? At the point of maximum height, Vy becomes 0. Okay. So if y is equal to 4t minus 5t square, then I can differentiate this equation. So dy by dt will give me Vy. Okay, and this Vy will be dy by dt, means d by dt of 4t, that will be equal to 4 minus dy dt of phi t square, that is phi into 2t. So Vy will be equal to 4 minus 10t. And at the point of maximum height, what will happen to Vy? It will become 0. So this is 0 equal to 4 minus, or I can write it as 4 equal to 10t, t is equal to 4 by 10. This is the time. Okay, did we get the time? Okay, so the time is different, right? Why is it happening? Y equal to 4t minus 5t square. By differentiating, we will get Vy is equal to 4 minus 5 2s are 10t. T is equal to 4 by 10. Vy will become 0. So I think I have solved this incorrectly then. This was 4 by 5, right? Oh, okay. 4 by 10 can be written as 2 by 5. Okay. This is 2 by 5, na? This is again 4 by 10 can be written as 2 by 5. So we are getting the time, this time, when this particle will reach the maximum height. Okay. Now, we can write this t again, put here in y, and we will get the maximum height same as 4 by 5 meters. So that's how you can deal this question in two different ways. Any problem in either of these methods? This is method 1, this is method 2. Any doubt? Have you got this second method? Just a little bit of differentiation which we have used here, and then we can find out the time when the ball will reach the maximum height. We can put this time t again in the value y, and we can get the h, maximum height here. No? Okay, so this was the last question, but we have got some more time. So let's see another concept then. Okay, variation of pressure with height or depth. Okay, so let's say that we have a container here which is filled with some liquid. This is liquid, and the property of liquid which we have to use here is its density. Okay, so this is density rho. Now let's say this is level 1, this is some level 2, and I have to find the pressure, and the distance between them is, let's say, small h. We have to find the pressure, difference in pressure with depth. Okay, so how can we do that? So I am giving you the derivation of that method. Okay, let's make a cylinder over here. Okay, a cylinder here. This is hypothetical cylinder. Okay, there is no mass actually inside the cylinder, any other mass. This is containing liquid only. Okay, so this is level 1, this is level 2. There is pressure P1, na? Let's say there is pressure P1, there is pressure P2 at this point. Now analyze this cylinder. Okay, so what is happening here? There is liquid. Okay, there is liquid inside the cylinder. Can you tell me whether this cylinder is in equilibrium or not? Is it in equilibrium? If we put this container on a surface and we are not accelerating this cylinder or this beaker, then obviously the cylinder should be in equilibrium, right? If it is in equilibrium, then the net force on this system or on this cylinder should be 0, right? So force here will be P1A1. Is it okay? I am writing F1 as P1A1 pressure into area. What will happen here? The pressure here will be equal to P2 A2 or simply A, because this area would be same. So I will take this area as same, right? So this is P1A, this is P2A. What else? Obviously, this container contains some liquid, so there would be the mass. This mass is, let's say, M, so there is a force mg downwards, okay? And net force should be 0. So I can write P1A plus mg. These are the two forces which are acting in downward direction, and P2A is the force which is acting in upward direction, P2A. Now, P1A plus M. M can be written as rho, that is density into volume. What is the height of this cylinder? What is the height? H, right? So the volume will become area of cross section into height H into G is equal to P2 into A. Now, as you can see, A will get cancelled out. This will become P1 plus rho G H plus P2. Oh, sorry, there is equal sign. This is equal. P2 minus P1 can be written as rho G H. Have we found out the formula? This is delta P is equal to rho G H. Okay, so you know the formula. Okay, this is the derivation. Okay, that's how we can find the variation of pressure with depth. Delta P is equal to rho G H. This rho is density of this liquid. G is obviously acceleration due to gravity, and H is the height or the difference on those two levels, on these two levels, from where you have to find the difference in the pressures. Okay. Now, this container was placed on surface, let's say, and it was not accelerating. But again, if we put this container in a lift, okay, so this is the container filled with the same liquid, rho. This is level 1, this is level 2. The height difference between these two as H. Now we have to find what will be delta P. And what is happening here? This beaker is going upwards with acceleration A. The analysis would be exactly same, but the formula would be a little bit different. Okay. Can we apply the same fundamentals here? Yes, we can do that. So this is cylinder of liquid again. Okay. There is pressure P1, there is pressure P2, and because of that the force will be P1A and P2A. Again, there is a mass, right? So I can write P2A, this force is in upward direction. P1A, this force is in downward direction. There is mass, obviously. mg will act downwards, and this whole system is going upwards. So the cylinder, this hypothetical cylinder, is also going upwards with the lift. What can I write now? Again, P2A, F net is equal to mass into acceleration, right? So P2A is the upward force minus P1A minus mg. Okay, this is the net force, and it should be equal to mass into acceleration. P2A minus P1A minus m can be written as rho AH. Now you know that we have already did it in the previous slide, right? M can be written as rho AH into G is equal to mass into acceleration. Again, mass, this mass can also be written as rho AH into A. A can be cancelled out. P2 minus P1 will be delta P is equal to rho HA plus rho HG, or delta P is equal to rho HG plus A. Rho HG effective. Okay. So this is the formula if the lift is going upward or the beaker is going upward. Is it okay? So variation of pressure with depth when it was placed on a surface where the acceleration due to gravity was g, and if it is placed in a lift which is going upward with acceleration a, this will again become g minus a if the lift is going downward with some acceleration a, but that acceleration a has to be less than g, because if the acceleration would become equal to g or greater than g, then the liquid will fall freely and there will be no pressure difference between any two layers. Okay? Any doubt in this derivation? No? Okay, students, so this is the end of our session. I have taught you many concepts here. You have to revise all of them, and I hope that you will be able to use these concepts in your further exams, in your upcoming exams. Good luck for that.